Hello and welcome to this session on network automation with Ansible Tower. I'm Patricio Martello.
Hi, I'm Matthias Guillemot, Network Solution Engineer.
In today's session, I'll provide a brief overview of Ansible, covering its fundamentals. Following that, delve into Ansible Tower, the officially supported version by Red, also known as AWX. I'll highlight the value it brings to your network orchestration, optimizing your day-to-day operations.
I'll demonstrate the power of Ansible Tower. I'll showcase its simplicity and agility by deploying an overlay VXLAN service on an existing spine and leaf network. You'll witness how Ansible Tower streamlines this process, making it both fast and efficient.
So, without further ado, let's begin. Before diving into Ansible Tower, let's do a very brief introduction about Ansible itself. Ansible is a software tool to automate provisioning and configuration tasks across multiple hosts. Let's delve into its capabilities. Ansible streamlines the process of provisioning resources, making it seamless and efficient. So, whether you're deploying applications, setting up servers, or managing infrastructure, Ansible simplifies the entire workflow. Its value is that you can define the desired state of your systems using simple YAML files, and you can let Ansible handle the rest. This eliminates manual configuration errors and inconsistencies. Whether it's routers, switches, or firewalls, Ansible treats network devices as just a special type of host. This approach streamlines network automation and ensures consistency across your infrastructure. Ansible scales effortlessly, allowing you to manage thousands of hosts. One of its big strengths is that it is agentless and does not require installation of any agent or plugin on the host or, in our case, on the network device. To sum up, you can use Ansible to automate provisioning, configuration, and network management tasks effectively. At the bottom of the screen, I added a link to another video in which we covered Ansible in more detail and more specifically how to combine it with Napalm to automate a multi-vendor network environment. So if you haven't watched that one already, you may want to check it out before you proceed with this one. In this video, we are focusing on Ansible Tower. What does Ansible Tower bring in addition to what plain Ansible can do? Ansible Tower offers an intuitive graphical user interface that simplifies the management of your Ansible playbooks. This can help if users are not well versed in coding. One of Ansible Tower's standard features is its ability to ask users for input variables. This dynamic functionality allows for flexible playbook execution tailored to specific needs. Combined with defined user rights management or role-based access control, it gives the ability to automate painful tasks and allow selected operators to perform specific actions as appropriate to the role. Ansible Tower goes beyond single playbook execution. You can create and manage workflows consisting of multiple actions. You can visualize your automation processes and orchestrate them seamlessly. Ansible Tower provides real-time updates, allowing you to monitor workflow progress and address any issues promptly. To be clear, you are still running Ansible under the hood, but Ansible Tower adds a few extras on top of Ansible. Unlike plain Ansible, Ansible Tower is not free, but if users are not experts in coding and need to be guided through a graphical workflow, or if role-based access control is a requirement, then this cost can be justified. With this very brief introduction, I hand it over to Matthias for the demonstration. Matthias, over to you.
Thank you, Patricio. Here is the architecture we'll use for this demonstration. A data center spine and leaf architecture with eBGP as the underlay routing protocol. eBGP is favored by many hyperscalers as the only routing protocol in their large spine and leaf architectures. It's also suitable for large environments with lots of nodes. On top of this architecture, we'll have an AWX server. We'll utilize AWX to push a VXLAN service onto this existing network, showcasing how streamlined and straightforward this operation can be. Before we proceed, let's quickly recap VXLAN. In this demonstration, we'll create a VXLAN between two clients, both of which will be Ubuntu hosts. To do this, we need to choose a VNID, VXLAN Network Identifier, that isn't already in use on the network. The VNID is encoded on 24 bits, allowing for up to 16 million services on the network. Next, we have the VTEP, Virtual Tunnel Endpoint, which will be equal to the far end leaf loopback. For example, leaf 1's VTEP will be the loopback of leaf 2, and on leaf 2, it will be the loopback of leaf 1. Then there are the access ports, which are the physical ports to which the client will be connected and bound to a service. Lastly, the tag will be set to 0 in our case because we don't want to tag to the Ubuntu clients. However, in most cases, there is physical host running virtualization with multiple VMs that need to be bound to multiple services, resulting in tagging on the client side. Now, let's move on to the demonstration. We will begin by the current state of the infrastructure. On client 1, we can see that we have the IP 192.168.1.1 already configured. On the client 2, we can see that we have the IP 192.168.1.2 already configured. The two clients are in the same networks. If we try to ping the IP of client 2 from client 1, 192.168.1.2, there is no reachability yet, because the VXLAN service is not configured yet. We will go on leaf 1, on which the underlay protocol is already configured with eBGP. We can see the loopback of leaf 2 in the routing table announced by eBGP. On leaf 2, we also have the loopback of leaf 1 in the routing table. We can also see that there isn't any service configured yet. Same on leaf 2. Let's move on to AWX. We will log in with the admin user. Before pushing the service, I will go through a few things in the user interface. First, the execution environment, which is key to understand. This corresponds to a Docker image with all the libraries and Ansible collections needed for the execution of the playbooks. For this demonstration, we will use ALE AOS EE built with a custom Ansible collection that we will share. Here it is. It is a custom Ansible collection built specifically for ALE OmniSwitches. This execution environment is built with our custom Ansible collection. You can simply reuse it with copying the URL. In case you want to reuse some playbooks that you have built with Napalm, as we did some demonstration with it in the past, it is also possible. It should be possible with others Ansible collection, just need to build the execution environment with Ansible Builder tool. Then, for security purpose, it is really easy to manage the rights that you want to give to the users. Here is an example. We have the user operator that is flagged as a normal user. We've added the user in ALE operators team with only the right to execute ALE operators workflows and read the output of the playbooks in the workflow. This user would not be able to modify anything other than what we gave him the right to do. Then we'll go in inventories, which correspond to the host file that we have when we run an Ansible playbooks from CLI. Here we have OmniSwitches inventory, including 2 hosts. In the detail of each host, we can see the user and the password that the user operator will not be able to see. Then we have projects, which is the place where all the playbooks are stored. It can be from a Git repository or other sources. In this demo, we will use ALE VXLAN synchronized on this Git repository. Here, we can see all the playbooks stored that we will also share. Then there is the credentials, where there is all the different credentials to access to Git repositories, for example. And here we have the templates tab, where we define all the playbooks and workflows. A job template corresponds to a playbook, and a workflow job template corresponds to the execution of multiple playbooks in a workflow. In this demonstration, we will use push VXLAN template that I will explain during the execution. Let's switch to operator user and execute it. First, we can see that the user operator has no access to the inventories, so he cannot see the login credentials of the devices. In the templates, he can only execute push VXLAN template. So let's launch it. Here, it will ask all the different variables needed to push this VXLAN service. We have the service ID, which will identify the service inside each switch. We will choose 10. The VN ID, VXLAN identifier, that we explained before. Here we will choose 10 also. The first switch will be leaf1. The VTEP, virtual tunnel endpoint, for leaf1, it is the loopback of leaf2, 4.4.4.4. The client is connected on port 111, so let's choose this one. Then switch 2 will be leaf2. The VTEP is the loopback of leaf1, so 3.3.3.3. The access ports connected to the client 2 is 111. And we don't want to tag the ports on the client side, so tag 0. We can click next and launch it. It launches a page to follow the execution. Here we can see the workflow with 3 tasks for each switch, executed in parallel. The first task is to check the availability of the service ID and the VN ID on each leaf. We can follow the detailed output of the playbook with clicking on the task. Here we have the output of the checks on switch 1, which seems to be OK, meaning that the service ID and VN ID specified are available. Then it will push the configuration on the leaves. We will cut the execution because the task that gets the first SDP ID available can be a bit long. The configuration has been successfully pushed on the leaves. We can click on it. And we can see that the SDP, the VXLAN, and the access ports configuration has been successfully pushed. The last task, check the status of the SDP. It is operationally up, so all is good. Let's check on client 1 if we can ping client 2 now. Great, the VXLAN service is working well. Let's check on leaf 1 if we have the configuration. Great, we have it. Same on leaf 2. And we can see that we have the MAC addresses of the clients in the MAC address table. Everything is working well. That brings us to the end of this demonstration.
This brings us to the end of this session. Let's wrap it up with some key takeaways. Ansible Tower operates your network more efficiently and rapidly without compromising security. You can easily manage user permission allowing precise control over services. Everything is customizable to fit your specific needs.
Thanks to automation and predefined templates, you can eliminate human errors in network configurations.
Workflow-driven network modifications enable you to maintain single reference for your network in a Git repository or any location of your choice. This proves incredibly valuable for troubleshooting.
These are just some of the benefits. We hope you enjoyed this session. We invite you to engage with us in the Spacewalkers Forum. Until next time, take care.
We encourage you to try it on your own. Thanks for watching. See you next time.